Welcome, ladies and gentlemen. We're going to do an extraction lecture, and we're going to talk about Kp, which is the extraction constant. The partition coefficient is how it can be read backwards. Coefficient spelled with a K, very common for European root words. A lot of C's become K. All right, so we're going to be mixing a solute, that's a thing that dissolves, in a mixture of two different solvents. There's always going to be an aqueous layer and an organic layer. And the definition of Kp is the concentration of the solute, that's how you read that, in the organic layer. In today's experiment, the organic layer is dichloromethane. In next week's experiment, the organic layer is diethyl ether. Both of those solvents are not soluble in water, and they're both non-polar, so they like dissolving organic compounds that are not very polar. So the concentration of the solute in the organic layer over the concentration of the same solute in the aqueous layer is Kp. So if we have a very big Kp, what does that mean? It means we have a lot more solute in the organic layer than in the aqueous layer, water layer, right? So down the bottom of the page, we're going to go to that right now. If Kp is much, much greater than 1, that's a big Kp, by the way. That means the solute greatly prefers, which layer was it again? The organic layer. Make it stand out a little bit here. Getting used to this new ChemDraw on this computer. All right, here we go. Solute greatly prefers the organic layer. Now, Kp just a little greater than 1. I'm going to edit this statement. How should I change it? So say Kp was 1.5. Slightly favors, I like that. The solute slightly prefers the organic layer. Slightly. So greatly, make that one red hot. Slightly cools down to maybe, I don't know, an orange. There you go. Okay. And what about Kp less than 1? That means you're going to have more denominator than numerator. What's in the denominator is the aqueous layer. So if you've got a Kp less than 1, your solute now slightly prefers which layer? The aqueous layer. Aqueous. Yeah, we'll make that black. Okay. And I think we've quite well figured out that this one's going to be greatly. Yeah. Organic. Get the organic blues here. Yeah, sometimes I get carried away with colors, but bear with me. We'll get through it. All right. It's still saving. Don't you be crashing on me. All right, so we're back to the top. We're going to do it. Yeah. Aqueous layer. Yeah. He was asking, he couldn't read this because in our room we have blockage of things with interesting stuff like a vise in front of the bench. But we get through it. So here we're told that we're told a few things. We have 1.275 grams of a chemical. We're going to call it chemical A. And we're going to extract chemical A out of a mixture of 1.313 milliliters of diethyl ether. What layer is that? That's the organic layer. And 838 microliters of water. And that's the aqueous layer for sure. And then they did the experiment. It's kind of like what you're going to do today. You do an experiment, and then you find out how much of compound A ended up in the ether layer. We always determine what's in the ether layer for one simple reason. It's easy to get rid of the ether layer and analyze what's left, because our organic solvents are going to be volatile. What's that mean again? Low boiling point. Water is very hard to get rid of. We won't ever analyze the water layer, but we will know what's in the water layer. Whatever doesn't go in the organic layer goes in the water layer. So we don't have to analyze the water layer. All right. So they analyzed how much of compound A ended up in the organic layer. So how much of compound A was there in the aqueous? How much was there? Tell me what kind of math I can do. The initial mass, which is, I'm going to listen to her very carefully. Say it again.
We can do it in milligrams.
I like doing it in milligrams. She caught on to where I was going because she noticed the units didn't match. She's making them match. We're at the level where I don't think we have to show this calculation. I will do it for you if you want. Are we okay? That's the amount total, right? 1,275 milligrams. And how much of that ended up in the organic layer? 641.6. Somebody give me a number here for the answer. And it's going to be 700 and something milligrams. Yeah. Okay, my math isn't what it used to be, right? Oh, it can't be 700. That'd take over 1,300. Duh. Sorry, say it again. 633.4. Okay. So that's how much compound ended up in the aqueous layer. Compound A, aqueous layer. That's what that said. I think we're ready for our calculation. Miracles of computers. Oh, man. It's just unfair, isn't it? Yeah, I don't use that too much. So how much solute is in the organic layer? Oh, we have that. And I need a concentration. Oh, no. Do we have to go to moles? Because it's the square brackets. I don't think I shared this screen at all, did I? Or did I? I did. I'm not used to the Zoom in this room. Sorry. I'm going to get panicky a lot. We're fine. So, yeah. So it says square bracket. You're used to that being moles per liter, right? Moles of solute, liter of solution. It doesn't matter what units you use today as long as they match. And we got that little warning up here. Concentration units can be anything that you want as long as they match. And ladies and gentlemen, milligrams per milliliter is a unit of concentration. I know it sounds like a density, but think about it. Milligram solute over a milliliter solution, that's concentration. So that's what we're going to do. Concentration solute in the organic layer. How many milligrams are in the organic layer? 641.6. And that's milligrams divided by how many milliliters of the organic layer? Careful. Milliliters of the organic layer. Yes. She said 1.313 milliliters. Now you go down to the aqueous layer. how much compound A is in the aqueous layer. Don't look too far, it's right above it. 633.4 milligrams divided by how many milliliters of water are there? 0.838 milliliters. Yes, I did a fast one there too, right? Microliters to milliliters. I'll just make the bottom blue. So just came across the blue water bridge the other day. So aqueous layer is blue. And it looks like it's just going to be a hair over 1. Units are going to cancel, aren't they? If they don't, you did it wrong. That's what this statement says here. You need the units to cancel. It's a partition coefficient without units. And milligrams per milliliter cancels milligrams per milliliters. And what do you got as an answer for me? Okay, I was way wrong. I'm not having a good day with numbers. 0.64. 64 again?
No.
640?
I got 646.
It was 6464.
Oh, it's
5. Okay. And there's no unit. So which category of K do we have here? Give me an interpretation. Yeah, it slightly prefers the aqueous layer. Now, if it was really tiny, like 0.06, right? Then we'd be saying it greatly prefers the aqueous layer. Are we sure of the math on this thing? I'm going to do it on my computer because I think my original estimate of this having to be a little closer to 1 was good. I'm bothered because I have a lot. Maybe I shouldn't be bothered. It's about a 50-50 distribution, isn't it? And we got a lot more. No, I take it all back. We got a lot more organic solvent than we have water. And we got about a 50-50 distribution of solute. Makes sense. About 0.65. Okay, I'm just always checking my numbers. Move this up so it just looks better. And we got a question. Yes, sir.
What is considered like greatly less than or greatly more than 1?
Okay, good question. He said, what is much greater than 1? I'd say greater than 100 would be loose. Oh boy. A loose interpretation of what I would call a cutoff for KP much greater than 1. This one just between 100 and 1. 1 to 100. And this would be 1 to 0.1. You're going in the other direction, right? 0.01. That's 1 over 100, right? 0.01. Going the other direction. And now, I'm sorry? We're interpreting KP values. So if you got a KP of 0.6465, it was correctly pointed out we're in category C for this particular chemical in this particular environment with these two liquids. And this one I'm going to say less than 0.01. There we go. For those that like numbers instead of words. Okay. So we're going to save that on top of this. No. Make it a 3-page document. Questions first, answers next. And we'll be doing this next question when we get a chance. Yeah, this. I'll save that. Now we're going to do something that's almost the same as your email assignment for experiment 4. In fact, I believe we're going to make this a second video. This will be our next one. So we're going to pick it up right here.